Okay, so we are going to start Chapter 7 today. Right below this picture in your textbook material, there's a little warm-up that you guys can go through to make sure that you understand everything that you need to before you start this chapter. But I wanted to start on this page. This is a brief look at what we're going to do in Chapter 7. And what we're going to see in this chapter, you guys, is actually the most important stuff we've done all year. You need to have those tools that we've built and used until this point, but really if you look at what we're doing here, we're actually starting to look at some of the algebra concepts that we're going to need to use for the next couple of years of our math careers at the high school. So first thing we're going to be doing is taking a verbal sentence and writing equations in one variable. That's what we're going to do today, and then the rest of the chapter we're going to be actually solving for those variables. So we'll be getting some problems where it's already set up for us and all we need to do is use our algebra skills to solve. So looking at this first example here, the first thing I want you to do is notice the definition of the equation. It's a mathematical sentence that uses an equal sign. We'll learn about equations and inequalities this chapter. Inequalities are a little bit different. Next, we're going to have to take expressions and translate expressions into equations, meaning you're going to have some words and you're going to have to make it look like a math problem. So to write a word sentence as an equation, look for the key words or phrases such as is, the same as, or equals. All three of these things right here, is, the same as, or equals, they all mean equals. What I'd like you guys to do is start this chapter by creating a note table for yourself. And the best way to do it is just to take all the operations that we know, so add, subtract, multiply, and divide, and start the chapter by putting this at the top of some notes. And every time you see a new word or you know some words that fit into these places, put those words where they belong. That way when you see them again, you'll know how to use them correctly. So again, is, the same as, or equals, those all mean equals. You can put equals off to the side here as well. We can put equals. And you can start your table by putting is, or the same as, or equals. But some of the examples of addition operation words, we have things like sum, subtraction, less than, difference. I'll put difference. Multiplication, a common one that students sometimes forget what it means, is product, and quotient. Okay, so these are just some examples. Now, again, you're going to see lots of them this chapter, so every time you see a new one and you're not quite sure where it goes, raise your hand and I'll help you put it in your table. If you just raise your hand and ask me what it means, I'm not going to help you with the operation until you show me the table where you're going to put it so that you don't have to ask it over and over again. So you guys, this is straight out of the book. All I'm going to do is kind of explain through it so that you can understand it. Hopefully at some point you'll be able to do this on your own and just look at these and kind of pick it apart. But first thing, what we have here is the sum of a number n and 7 is 15. Well, this whole entire phrase, you'll notice they highlight it blue. The sum of a number n and 7, you're going to put n plus 7. And then you have is 15. Well, so your equation, your answer is n plus 7 equals 15. A number y decreased by 4 is 3. So again, all this, a number y decreased by 4 is y minus 4. Order matters here, so make sure you don't put 4 minus y because that's incorrect. And then we put is 3. So you just get your equation y minus 4 equals 3. 12 times a number p equals 48, so you can just put it like this, or you can put 12 with an x, p equals 48, but again it says times a number p, so we're going to put 12 times p equals 48. We don't have to solve these yet, that doesn't come until later, so all we're doing is writing this for our answer. So what I'd like you to do is pause the video and write the equation for all 4 of these, and once you're done, go ahead and hit play, and hopefully you guys get these right. Okay, so again, hopefully you paused and tried these and got these same answers. Order doesn't matter for addition and multiplication, So as far as the ones numbers 2 and 3 go, the order can be switched. You can put G times 5 or 5 times G. It doesn't matter. Same way here, 10 plus K or K plus 10. But B minus 9 has to be B minus 9. It says 9 less than a number B, so that means we're taking it away from B, 9 less than B. The quotient of Q and 4, we put Q over 4 equals 12. So again, make sure you got all these right. If you didn't have some of these words in your table, make sure you add those words to your table. The next one is just another problem where we have a math problem that we're going to take from words here. So it says 10 servers decorate 25 tables for a wedding. Each table is decorated as shown. Let C be the total number of white and purple candles, which you can, says which equation can you use to find C? So if you look here, we have 4 white candles and 1, 2, 3, 4, 5, 6 purple candles. So if we look at this here, we need to figure out how many ways, or how many times we need to do this with our purple and white candles. We know that 4 and 6 needs to be the only thing in parentheses, and we're going to add them. So A and C are automatically out. We don't care about those. And since we have not 10 tables but 25, we're going to say that the equation looks like this. C equals 25 times 4 plus 6 in parentheses. Again, I try to add these boxes every time I can when I'm putting together your guys' videos. Looking here, we have one of those words that we can add. It says eliminated means subtraction, so I would add eliminated underneath your subtraction column in your table. That one's going to be pretty useful for us. It says after 2 rounds, 24 students are eliminated from a spelling bee. There are 96 students remaining. Write an equation you can use to find the number of students that started the spelling bee. Well, this one is going to be one where we can actually solve, but we need the total of number of students that started the spelling bee minus the 24 that have been eliminated, and we're going to end up at the 96 that are there now. So in order to find out how many students started, you'll learn how to do this tomorrow, but what we'll do is add this 24 to the 96 to figure out how many students started in the spelling bee. But as far as your answer goes, it's S minus 24 equals 96. So it says you entered an elevator and you go down 7 floors. You exit at the 10th floor, and it says to write an equation to use to find your starting floor. So for number 5, when we do this, we are going to say our starting position minus 7 because we went down 7 floors, and it says we are going to end up at the 10th floor. So S minus 7 equals 10. That's pretty similar to example 4. It says together you and a friend, for number 6, together you and a friend save $52. Your friend has 28. Write an equation you can use to find out how much money you have. So let's put you as Y, and you're going to say plus your friend's $28 is equal to how many you guys have together, or how much you guys have together, which is 52. So using this equation tomorrow, we'll be able to find out how much money you have. A typical person takes about 24,000 breaths each day. Write an equation you can use to find the number of breaths a typical person takes each minute. So if you know days in one day, this one is going to require a little bit of work. What we need to do is figure out how many minutes are in one day. So what you'll need to do is figure out, okay, so I know I have 24 hours in one day, and in each hour there are 60 minutes. So what you're going to do is take 24 times 60 to figure out how many breaths a person can take each day. I believe what you get is 1440. Once you find that, you're going to say 1440 times x is equal to 24,000.